Welcome on and all. This POC was built to answer a real question that every AI team faces. Which retrieval strategy should we use? And does the answer change depending on what the user is asking? The three chips at the bottom, vector, graph, tree, correspond to the three parallel pipelines we built. Everything uses the same source documents, the same LLM, and the same evaluation metrics, so the comparison is fair. The core insight here is that RAG is not one size fits all. A question like, what is the password policy, is fundamentally different from what happens to an employee on a PIP if there is a security breach. The first is a lookup, the second requires connecting two separate policy domains. Without data to back the choice, teams default to vector RAG for everything and leave accuracy on the table. The goal strip at the bottom states the POC objective: prove which strategy wins per question type with real numbers. Documents feed into three separate indexing pipelines simultaneously. The vector index chunks text and embeds it into ChromaDB using TF-IDF. In production, it will be swapped to ADA002. The graph index uses an LLM to extract entities and relationships, then stores them in a network X directed graph where every node keeps a back reference to its source passage. The tree index detects headings and subheadings and builds a hierarchy tree. No LLM needed, just pattern matching. The evidence normalizer is which is present in the footer is the key design decision. Every retriever outputs the same canonical evidence object, so the answer generator is completely method agnostic. Normal RAG is the simplest, embed and retrieve. Graph RAG is the most powerful but most expensive. Each text block here requires an a LLM call during indexing. Tree RAG is the most targeted. It navigates document structure rather than semantic similarity. The best for strips at the bottom or the starting hypothesis, the evaluation harness will validate or challenge these assignments with real data. The classifier runs first as a zero-shot LLM prompt with the keyword heuristic fallback if the LLM call fails. The color-coded strategy badges on the right make it easy to see the routing logic at a glance. Key point is these heuristics are the starting assumptions, not fixed rules. The evaluation results may reveal that aggregation questions actually perform better on graph RAG than the tree RAG for certain document types. And the architecture allows you to update the routing map based on that finding. Fair comparison is the whole point of a POC. If the answer generator used a different prompt for each method or different temperature settings, you would be measuring the prompt quality rather than retrieval quality. Everything that can be held constant is the evidence schema on the right is the mechanism that enforces this. Once any retriever's results are normalized into source, doc, location, retrieval method, score, text and metadata fields, the generator has no idea which retriever produced them. The evaluation layer has no idea either. Recall catches whether the answer actually contains the right information. Retrieval relevance tells you if the retriever is finding the right chunks. A high relevance score with the low recall means the retriever found the right passage, but the generator failed to use it. Hallucination flag is a simple but effective proxy if numbers appear in the answer that do not exist in any retrieved passage. Something was made up. Citation rate rewards the system for being transparent about its sources. The four output files at the bottom mean the evaluation produces artifacts a client or stakeholder can inspect directly. Vector RAG is the workhorse, fast, cheap, and surprisingly accurate for well-scoped factual questions. Its Achilles heel is multi-hop reasoning. It can retrieve the right passage about password policy and the right passage about incident response, but it cannot connect them on its own. GraphRag solves exactly that problem, but at a real cost. LLM extraction during ingestion takes 2 to 5 minutes on a modest document set, and quality depends heavily on how well the LLM identifies entities in your specific domain. Tree RAG is the sleeper win. It requires no LLM at all for indexing, runs in milliseconds, and is highly accurate for any question that references a chapter, section, or heading by name. Let's see the production recommendation. The 5 routing steps map directly to the question types that we tested. The key message is that all 3 indexes should be deployed together, not just the winner. Different question types will always exist in a real user base, and the dynamic orchestrator pays for itself by routing each question to the retriever most likely to answer it correctly. The technology stack, note at the bottom, is opinionized but practical. ChromaDB or Quadrant for vectors, Neo4j for production scale graphs, PostgreSQL JSONB for tree storage, and GPT-4o Mini or Cloud Haiku for cost efficient LLM calls. This is a kind of hands-on guide for anyone who wants to run the POC themselves. Step 1 through step 5 take under 10 minutes excluding the graph indexing step. Important caveat for step 2, the graph indexer calls the LLM once per text block. So on larger document sets it can take 5 to 15 minutes. The embeddings run entirely locally using TF-IDF, the only API call that requires a key in the LLM for graph extraction and answer generation. Step 4 is the most useful for the live demo. So let's we will see this in the upcoming videos, the live demo presentation with a challenging multi-hop question to show all the 3 approaches side by side in real time. So let's see some takeaways to the business objective that was stated in the slide 2. The most important takeaway is number 1, no single strategy wins universally. This is not a failure. It is the finding that justifies building the dynamic orchestrator in production. Takeaway 5 is often uh, underappreciated. The POC does not just demonstrate the strategies, it also validates or corrects the routing heuristics. If the data shows that tree rag actually outperform graph, rag on comparative questions for your specific document types, you update the routing table. The POC makes that discovery possible before you commit to a production architecture.